Hi, good morning students here. Let's start our electrochemistry chapter. Some basics also we'll discuss right now. So first of all, you know very well electrochemistry nothing but a branch of science which deals about the spontaneous redox reactions only. The spontaneous redox reactions we have to remember some basic terminologies there, that is one nothing but a reduction and oxidation. So remember reduction nothing but a gaining of electrons. Oxidation nothing but loss of electrons only. Remember reduction nothing but a gaining of electrons, oxidation nothing but a loss of electron. Reduction also known as addition of hydrogen. Very clear, no? Reduction nothing but addition of hydrogen also, and removing of oxygen also known as reduction only. Once again I'm saying here, reduction nothing but gaining of electrons, reduction also known as the addition of, look at the addition of hydrogens. Remember addition of the hydrogens only. Addition of hydrogen and removing of oxygen. Removing of oxygen. Minus O2 I mentioned, removing of the oxygen atom also. So here this is nothing but here reduction only. Oxidation nothing but a losing of electrons. Losing of electrons known as oxidation only. Reduction also can say the decreasing in the oxidation number. Decreasing in the oxidation number. What decreasing the oxidation number means? Suppose I'm taking the zinc, Zn2 plus is there. So zinc atom is there, no? So Zn2 plus, it is gaining of 2 electrons. When it gains 2 electrons, it deposit as a zinc. It is becoming as a zinc solid only. So what happened here, just consider in this equation is there, no? Initial zinc having the charge is +2, after chemical reaction become to the 0 only. So nothing but here decreasing of oxidation number also is known as a reduction only. So next one oxidation, nothing but loss of electrons only. Oxidation nothing but loss of electrons. So you know very well next one is here oxidation nothing but a addition of oxygen also known as oxidation only. Addition of oxygen and removing of hydrogen atoms also known as oxidation only. Removing of the hydrogen atom also is known as oxidation only. So how can you remember oxidation means? You can remember simply oil rig. What is oil rig? Oxidation nothing but a loss of electrons. Oxidation is nothing losing of electron, reduction nothing but a gaining of electrons. So these reactions which oxidation and reduction occur with simultaneously, then it's called redox reaction. Without oxidation there is no reduction. Without reduction there is no oxidation. Whatever the chemical reaction happen in our daily life, all are the concentrated with the redox reactions only. How can you say, sir? Means some examples. If you take one apple, when you cut the apple, when you place in atmospheric conditions, after 5 minutes you just notice that it becomes somewhat brown color. Nothing but a apple contains small amount of iron. Some enzymes are there under oxidation only. If you take brinjals, what are the materials are there under oxidation? So even though you remember rusting of iron also not redox reaction only, no. So redox reactions are very important in our daily life only. Next, go for next slide here. What is the electrode? Nothing but look at the electrode. What is electrodes? Are a metallic rod, either aluminum, either brass, either carbon, either copper, either iron. In this, remember, carbon electrode is known as inert electrode. Why they call inert electrode means these can never take part in chemical reactions. Next one, lead electrode, nickel, mercury electrode, tin electrode, zinc electrode. These are generally called as active electrodes. Why they call active electrodes means they may be dissolved in the electrolytic cell, they will be deposited on the electrodes only. So these electrodes are take part in a chemical reaction. These electrodes doesn't take part in chemical reaction. Even though just consider platinum also doesn't take part in a chemical reaction. Platinum is also called as an inert electrode only. Platinum is inert electrode. So here the electrode doesn't have any charge. Okay, electrode doesn't have any charges, then based on the connect with the battery. If you are connected with the battery, suppose the battery is containing the positive charge here and here negative charge. Here positive charge is general I'm taking is the anode, negative charge is cathode. I'm saying electrolytic cell. If you say electrochemical cells is there, no electrochemical cell is a positive charge is there, no here anode having negative charge, cathode having positive charge. I'm saying very clearly, electrodes are nothing but a metallic rod, or else in electrodes nothing but where the chemical reaction takes place in the electrochemical cells known as electrodes only. The electrodes are classified as a inert electrodes and active electrodes are there. The electrodes are classified inert electrode and active electrode. So based on the chemical reaction they have been classified. So let's have some idea view is there now, just consider here. Next one is there now, electrodes. Look at the anode they mention, electrode at which oxidation half reaction takes place. Suppose one chemical reaction we are divided into two halves are there. One is oxidation, one is reduction is there no. Where oxidation is takes place, nothing but oxidation occurs at anode only. Already discussed about the lone. Remember generally left hand side anode oxidation only. Cathode nothing but reduction only. Look at the cathode nothing but reduction only. Remember car. Okay, cathode nothing but reduction only. So here remember next one is cathode is reduction is there no. So in this cell is this is like electrolytic cell, whatever the cell is then here both anode cathode both are there along with electrolyte. A blue color electrolyte and copper sulfate they have taken is there, they will connect with the external circuit only. External circuit they will be connected. So look at here students, some basic idea is there now. Electrolyte, those substances that produce an electrical conducting solution when it's dissolved in polar solvent. Nothing but here if any material dissolved in the solution, if it carries the electricity then it's known as electrolyte. Suppose it's not carrying electricity then it's called non-electrolyte only. Suppose I'm taking here the two electrode is I'm taking one is the anode, one is cathode, or it is conservator maybe. Okay, now based on these no electrochemicals, no electrolytic cell. Suppose I'm taking two electrodes. When I place ethanol, when I connect to the external circuit, there is no flow of electrons will be takes place. Why? Because ethanol is a weak electrolyte. Suppose I'm taking the KCl, when I dissolve KCl, when I connect electricity, it acts as best conductor, light is glowing up now. Why? Because that means now here KCl is a strong electrolyte, undergo decomposition easily, they produce the ions. Clear, you know, look at the edge, consider alpha value, degree of dissociation value is equal to 1 only. Equal to 1. Alpha value is there, no, degree is equal to 0. No dissociation will be general doesn't takes place only. So next one is that here acetic acid, weak electrolyte is there. Weak electrolyte is then here the degree of dissociation is not equal to the 1 only. That's the reason why you can see the very slight glow will be takes place. So here no dissociation is takes place, the complete dissociation takes place, here partial dissociation will be takes place. So this is acting as strong and weak and non-electrolyte only. Suppose if you dissolve urea here, it's acting as non-electrolyte only. Glucose also, and urea, glucose, fructose, galactose, whatever the sugars is there, no, they will have starch as they will doesn't conduct electricity only. Electrochemical cell is there, no, that converts chemical energy into electrical energy. In a simple cell, two electrodes are connected by the wire. These two electrodes are connected by the wire only. Okay, look at here. Next one is an acidified solution act as electrolyte. Here, whatever the solution is taken, they have to add small amount of the acid only. That's why the mention is the acidified only. Some acid they will use, either sulfuric acid, whatever acid they will use here. That's why acidified. So why they are using sulfuric acid? What are the acids means? No, they act as electrolyte. They increase the conducting capacity. Clear? So next one is there now current pass from the cathode to anode. Look at the current is just imagine here current is moved from there, just consider from the look at the electrons are moving from here to electrons are moving in this direction. Okay, electrons are moving in this direction and current move in the opposite direction. Current move in the opposite direction. So this point you remember, no? So electrons are moving in the direction. Current. Look at here, just consider this is the electrolytic cell only, general cell only. Remember here anode is there now, and look at electrochemical electrodes of a simple cell is anode. One electrode is the anode, some other one is acting as cathode only. More reactive metals become the anode, very important. More reactive metal general anode only. Okay, less reactive metals become the cathode only. Oxidation half reaction occur at anode only. This remember, this O remember, no, oxidation half happening here. Next one is cathode is nothing but here cathode number reduction is happen. Reduction of half reaction occur at cathode only. Negative terminal, generally anode is negative terminal. When is negative terminal? If cell producing electricity, if cell taking electricity acting as a positive one. Okay, here positive terminal, cathode is a positive terminal only. In this one you remember electrolytic cell, electrochemical difference is there. So suppose I'm taking the simple electrochemical cell, I'm taking simple electrochemical cells. This is the ammeter which measure the electrode potential, how much electrode potential are producing here. Here one cell is there. This cell is, I'm taking the one solution, what, electrolyte, acidified electrolyte. They add some acid along with electrolyte only. Here electrodes are there. This electrode doesn't contain anything is there. Look at it, doesn't mention anything is there. So remember here, when you go for next one is step is there. Look at here, activity one will do here. A small beaker, you take a small beaker. In this small beaker, dilute sulfuric acid you place, dilute sulfuric acid, and you place a zinc metal. So what happened, you did in the same experiment in the laboratory in 10th standard. When you place a zinc metal in the sulfuric acid solution, the bubbles are generated. Look at it, the bubbles will be generated. So what bubbles are coming here? Look at it, some bubbles are coming here. What bubbles are coming? The bubbles are nothing but a H2 gas is coming. Why H2 gas is coming? You have to remember, no? Remember H2 gas gives a pop sound. Here why H2 gas coming? Why H2 gas coming means, look at there, you add sulfuric acid to solution because depend, look at the zinc strip is there. So what happened here? Oxidation happens, some other reduction is happening. You'll get very clear here. Look at here, just consider here the continue the process. Look at it, I'm taking the same chamber, a dilute sulfuric acid is there, a metallic rod is there. So in this metallic rod, what happened means here most important one is, you remember, so the time leads on what happened there, here zinc atoms are, they become to the Zn2 plus ion. Zinc atoms are, they become to the Zn2 plus. Zn2 plus. When it's back into Zn2 plus, nothing but oxidation only, no? They happen at the oxidation only. Zinc always under oxidation only. Okay, oxidation. So what happened here? Electrons are produced. Negative charge. Electrons are coming. Okay, negative only. So electrons are coming only. So what happens? Similarly, if we take sulfuric acid, breaks into the H plus and breaks into the H plus and SO4 2 minus, SO4 2 minus 1. So what happens here? Look at here. Whenever electrons are generated, here where negative charge is there, positive charge is there, no? Because of positive charge and negative, so some potential difference generated is called as a oxidation potential. You know, this is called as a oxidation potential only. So remember here oxidation potential. You'll go for next slide, you'll get very clearly what they mention here. Very just imagine here. Look at here, just consider zinc solid losing electron, they form a, look at 2 electrons are lost, they form a Zn2 plus an aqueous solution. Initial zinc is a solid only. Time leads, what happened there, here zinc dissolves in the solution. Next step is then sulfuric acid breaks into the H plus ion sulfate ion. This H plus ions gains electrons, they form hydrogen gas. So what happened here? Oxidation happen, here reductions happen. Both are takes place only in single cell. Clear? So next one is, look at the oxidation is oxidation half cell is. Why is there oxidation half cell means, no? If you consider only oxidation process, 1/2 cell, reduction process, 1/2 cell, total will be, look at it. This oxidation means zinc solid becomes Zn2 plus ion plus 2 electrons. Clear is there, no? Here similarly here 2H plus ion gains 2 electrons, they form hydrogen gas. If you balance the chemical reaction, zinc will be there here. 2 hydrogen atoms are there, 2 electrons also is there. Clear? This side, look at this is LHS. Remember all are the LHS only. Okay, here LHS, what is there? LHS is considered this one, this is the LHS only. So what happened here? Just go for this is the RHS. RHS. So these electrons are there here, these electrons will be cancelled out. So Zn solid plus 2H plus ion gives rise to Zn2 plus ion aqueous solution plus hydrogen gas. Okay, hydrogen gas is coming. Why hydrogen gas is coming here? The electrons are gained from the zinc only. So clear is there, no? So just consider here. So the overall reaction they given complete reaction. Zinc react with sulfuric acid. These 2 hydrogen atoms are replaces. Why 2 hydrogen atoms are coming means zinc lost 2 electrons. These 2 are become hydrogen gas only. This is nothing but simple electrochemical cells only. Suppose some other activity you are taking here. Here taking the, look at here, just consider here 2 electrodes I am taking. One is copper electrode, one is zinc electrode. I am not taking any electrolyte here. So no deposition will be takes place only. I am taking HD by sulfuric acid here. So what happened here? Observed zinc strip dissolved, gas bubbles are liberated the copper electrode. Look at here, just imagine when I connect with the external circuit. Look at it, when I connect with the external circuit, what happened means, just imagine if you connect to external circuit, electrons are generated. So electrons are generated, and what happened here, Zn2 plus ion will comes in the solution, Zn2 plus ion. So what happened there, electrons coming, electrons slowly move from here to here only, no? Whenever electrons move from here, hydrogen gas, H plus gas, approaches the electrode and gains electron, they become hydrogen bubbles will come out. So what happened there, near to the here zinc strip oxidation happen, near to copper is reduction is happen. Clear? No confusion, no? So look at here, in this one is, just imagine here, if you take the second equation, look at very clearly. Okay, look at here, in this condition also, zinc loss electrons, hydrogen is gains electrons, hydrogen gains electrons from what? From the copper, near to copper rod only. Reduction happen at the copper rod, but copper rod doesn't take part in chemical reaction. Okay, zinc will get negative terminal only. If you take some other reaction, some other activity, which is considered third activity I'm taking here, I'm taking one same zinc strip and copper. Observe iron I'm taking, iron here I'm taking here, the iron strip and copper. Similarly, what happened there, just when compare with iron and copper, iron is more reactive. Iron lose electrons, so iron will now iron lose electrons. Electrons move from here to here. Copper gains electrons, so hydrogen will come here and loses gains electrons and undergo reduction process. Look at here, iron lost 2 electrons, oxidation happen. Hydrogen gains electron, reductions happen. So when you balance the chemical reaction is there, no, Fe to H plus ion gives rise to Fe2 plus and H2 gas. Oxidation, iron under oxidation, negative terminal. Reduction happen at cathode, copper and positive terminal only. Reduction, positive terminal. Oxidation, negative terminal only. So if you go for some other one is some other chemical reactions are there, no? Look at here, some other one is here. Look at here. Okay, sorry. If you take some other chemical reactions are there, no? Some other chemical reaction. Look at here, just consider the complete reaction is the oxidation reduction is there, no? Here zinc, initially zinc oxidation number is 0, hydrogen oxidation number is 1. So here zinc oxidation number is +2, hydrogen oxidation number is 0 only. So what happens, how many electrons are lost by zinc is there, no? 2 electrons. So multiply with 2 H plus, and it gives 2 hydrogen, H2 gas only. So what is the reduction happen here? Look at the hydrogen undergo reduction process, zinc undergo oxidation process only. Both will be takes place. Both happen simultaneously. So look at here, students, very important is there, no? If I take the 2 half cells I'm taking here, 2 half cells are in this 2 half cells are there, no? First half cell is zinc I'm taking is, why a zinc I'm taking is there, no? According to IUPAC convention, first oxidation you have to take, next reduction you have to take only. Clear? So what I mean here, these 2 cells are initial, the 2 cells are this one half cell, this one half cell. What happened here, the times leads on, zinc atoms are slowly dissolved in the solution. So the concentration I'm taking here, concentration is 1 molar concentration. 1 molar concentration. Temperature is 25 degrees Celsius, standard temperature only. 25 degrees Celsius. So what happened then here, 25 degrees here, what happened, just consider the times goes on, the concentration of Zn2 plus ion is increases. Concentration is increasing only. The time goes on, concentration of the copper ion will be decreased here only. So this is the internal circuit, this is external circuit only. Okay, external circuit. If place one any voltmeter is there, it will measure how much volt is generated only. So how much volt will be generated only. Suppose if I connect to some external circuit, is there. Okay, external circuit. Generally what happen here, the zinc undergo oxidation, copper undergo reduction only. So look at zinc undergo oxidation, copper undergo reduction. If you observe the electrode potential of both electrode potential, look here, how much volts generating, 1.1 volts only. So total electrode potential E value is equal to E cell. The total this is complete cell, E cell is equal to E cell is equal to E oxidation. Here just means E reduction minus of E oxidation. E oxidation. It's very important. Total cell potential nothing but here how much potential generating here, the value is equal to minus 0.76 volt. 76 volt. Oxidation on reduction, how much is there here, plus 0.0.0 0.34 volt, 0.34 only. The substitute value is there, no? E cell, what you get, the E cell is equal to E cell is equal to 0.36 minus of minus this value minus 0.76, minus become plus only, no? So what will get? I will get the 1.1 volts will get. So the total potential value can be calculated by, he look at the, just consider here right minus left. You can remember E, first one is E mention is there, no? E right minus E left. Clear is there, no? E right minus E left. This is the only chemical reactions only. So suppose just look at here, I'm just consider some other second one step I'm doing here. If the cell producing potential is 1.1 volt only, you look at the, I'm connect some external circuit is there. If cell potential value is there, no, less than 1.1 volt, cell potential value is there less than 1.1 volt. Initially what happened there here, look at the what, look at the, suppose you mention is there, no, electrons are flow from the zinc to copper. So electrons are moved from the here to here. Clear what happened? The time load. Next one is zinc dissolves at the anode, copper deposit at cathode. So the time load, zinc will be slowly dissolved on the anode, copper will be deposited. Suppose if I take the electrode potential value, then if I take the electrode potential value, this is very important. If that one is more than here, electrode potential outside external battery is like, no, what happened there? Whatever the reaction takes place in this direction, it undergo reverse. What happened there here, slowly copper will be deposited if the if the cell potential is more than outside battery is more than. The next one is then here zinc will be deposited, so it's depend upon the cell is depend upon the out external circuit only. Clear is there, no? Here what happened is mentioned here, suppose here the electrode potential value outside the battery value, this cell how much amount of volts is producing, same volts battery you kept here, so the reaction occur equilibrium reaction. So what happened there, no flow of electrons will occur, no change in the chemical reaction will be takes place only. So this is very important, students. So just imagine once again I'm saying here, if the electrode potential here, how much potential is generating, that's value is, you can hear less than 1.1 volt, 1.1 volt, general chemical reaction happen, zinc loss electrons, copper gains electron. If the electrode potential value is there, no, it's more than external one is, then no, what happen there, reaction happen, the reverse reaction. So clear is there, no? So here this one is happen. So this is a reaction, very important. They asked last year, they asked. Next one is galvanic cell. Look at here, Jogesh, galvanic cell is, you know, in this device, the Gibbs energy of the chemical spontaneous reduction reaction. Okay, now in this device, the Gibbs energy of the spontaneous redox reaction is converted into electrical work, which may be useful for running of the motor, other electrical gadgets only. Suppose I'm taking Daniel cell discussed earlier here, zinc undergo oxidation, copper undergo reduction is only. Some electrical work is produced. This electrical work generate electricity only. So work is doing, no, work means you remember delta G is equal to, work means you know very well, the work is equal to delta G is equal to delta H minus T delta S, no, delta G is equal to delta H minus T delta S, Gibbs free energy formula. So here also is there, no, some work is generated. This work how will calculate? Look at the work is there. The first one is copper under reduction process. Here also one work. Zinc under oxidation process. Here also one work is there. How they'll represent here this work, electrochemical work in the electrochemical cell. Look at the electrochemicals how they are representing means here. Look at here. Look at how they are mentioned. Delta G is equal to delta H minus T delta S. So look at here, students, this comes from electrical, so electrochemical cell and Gibbs free energy relation only. Delta G is equal to, remember, delta G is equal to minus NF E naught. Here N stands for number of electrons gain and loss. zinc Zn2 plus no 2 electrons will mention. Fired nothing but 96,500 coulombs. E cell nothing but how much potential generated. Okay, how much potential generated. For suppose if you are measuring the electrode potential standard condition, we mention is a G delta G naught is equal to minus NF E naught only. Minus NF E naught only. So here this value will calculate it. Suppose I will get one simple example. The mention is there now zinc under oxidation, copper under reduction, delta G is equal to minus 2 F E naught. How much cell potential potentially 1.1 volt no 96,500 coulombs and 2 volt. Clear then if suppose if you multiply this equation with 2, what you'll get total value 2 into minus 2 F E naught on 4 F E naught on. So if you measure the electrode potential at standard condition, delta G naught is equal to minus N of E naught cell is there, or delta G is equal to minus RT ln K. When is RT ln K using no? Whenever the chemical reaction in the equilibrium positions only. Look at the students here. Remember here most important standard cell potential is there. Suppose if a cell is, if you take one concentration cell is there, how much amount of electricity produced by standard electropotential. The cell potential at standard conditions can be found like that is there, no? E is total cell potential E naught. E is naught stands for 1 molar concentration, temperature is 25 degrees Celsius. If you take a gas is there, no? Here gas one is 1 atmosphere pressure only. E minus reduction you have to take. Next one is E minus E. Look at the IUPAC convention is if they are given oxidation half cell is there. No, suppose if they are given oxidation is oxidation of J. Look at the Zn. Remember here zinc become to the Zn2 plus. Zn2 plus. So oxidation, sorry, Zn2 plus oxidation is there. No, its value is equal to minus 0.76. More 0.76 only, no, 0.76. If they are taken a reduction half cell, no, it's become to positive, opposite only. Clear? So what I mean here, just consider here is cell nothing but reduction and oxidation only. You're going to calculate the calculation also. I'll mention here very clearly. Look at here, just consider E reduction. They mention E reduction half cell is minus 0.76 only. Okay, now here they consider E oxidation generally here for the oxidation process only. It mentions generally E standard reduction versus minus 0.76. E reduction of the copper. This is copper value, this is zinc value only. Clear? What you'll get here, you'll get the value is equal to here. Look at the E reduction is equal to 0.34 volts and E reduction of the anode only minus 0.76 only. Clear? So I'll get the 1.1 volt. It means one cell is producing of the zinc and copper cell is this much voltage is producing only. Okay, this much volts only producing only. Okay, consider